Hi everyone, we are in the third section of our chapter 6, talking about linear equation and simultaneous equations in particular. So the main information that we seek to explain in the chapter is simultaneous equations and how to solve such equations. First of all, in this section, we want to give you a short explanation about solving and finding graphical equations, graphical solutions. So in this session, we want to graph linear equations in a pair x prime or x, y prime or y, to find the intersection point of these equations, y. So first of all, what is the concept of graphical solutions? We know that linear graphs are used to solve simultaneous equation because each linear equations, it is a straight line on the repair. It is a straight line. So the graph of linear equation is a line. So if we graph two lines, what are the different positions of this line? This line could be, for example, could intercept each other, or these two equations could be parallel to each other, or these two lines could be congruent. Okay, so the intersection, focusing on the second case or the first case, when two lines intercept each other, we obtain an intersection point, and then this intersection point of two linear equation is the simultaneous equations. So we only read the solution graphically. So the graphical method consists of drawing the table values for each equation by choosing any x value and y value by substituting and solving the equation. Then we draw the lines using the particular point. Of course, we look for the intersection point. This is our simultaneous equation. What about drawing x value and y value by substituting? We choose at least 3 points. The main points and the particular point for us are the x-intercept and y-intercepts. How? We already explained it in previous sessions. What we mean by x-intercept when y equal to 0 by substituting a y equal to 0 in the equation. What we mean by y-intercept, the intersection between the line and y-axis, and the y-axis have equation x equal to the y equal to 0, so we substitute x equal to 0 in our equation. Okay, we draw the line and we go on. So let's move to a numerical example. Use this table of values to graph 2x minus 3y equal to minus 7. Normally, we take when x equal to 0. When x equal to 0, we have a 2 by 0. We substitute the 0 for x in this equation. So we obtain 2 by 0. 2 by 0 equal to 0, like we don't have anything here. So minus 3y equal to minus 7. So we divide both terms of sides by minus 3 to obtain y equal to minus 7 over minus 3. So 7 equal to 7 over 3. 7 over 3 is equivalent to 2 to 1 over 3. And if x equal to 2, so if x equal to 2, we obtain 2 by 2, we'll obtain a 4. And 4, we move it to the right-hand side of the equal, we obtain minus 7, minus 4, minus 11. So minus 3y equal to minus 11. So normally, y equal to minus 11 over minus 3 is 11 over 3. 11 over 3 is equal to 2 over 3. And when x equal to 4, so we'll obtain 2 by 4, 12, 2 by 4 equal to 8. And if we move it, we obtain minus 15. So minus 3y equal to minus 15. Y equal to minus 15 over minus 3 equal to 15 over 3 equal to 5. Okay, so we have 3 points 3 particular points for each one. In the same way, we obtain 3 particular points for the second equation. So we want to draw our line, our both linear straight lines with using 3 particular points for each. Okay, and the first one. So to draw the first one, I noted here 0 to 1 over 3. So 2.3 for the second. So x equal to 0. Good. And we go up because the y is positive. 2.3. 1, 2, 2.3. Good. This is our particular point. For x equal to 2, so for the right, horizontally on the x-axis, on the right of 0 because x is positive, so 2. And we go up because the y is positive, we go up 2 over 3, so 3.66. So 1, 2, 3, and before going to 3.67. So this is our second. Our third one, 4 or 5, exactly. We have an exact value here without any need to approximate it. So 4 over 4 and 4 positive. So 4 for x and 5. We go up 5 steps. 1, 2, 3, 4, and 5. This is the third one, and we join these points to obtain our first straight line. Okay, the second straight line is we can obtain it by joining these 3 particular points: 0, 7, 2, minus 1, and 4, minus 9. It's easy to, for example, 0, 7, 0, 7, 2 minus 1, 2, and we go down 1 because the y equal to minus negative number. So we go down minus or 1 step down or above, under the x-axis. So this is the first one, and we have a second one, and we have a third one far away. So we join these 3 points to obtain our equation for x plus y equal to 7 to obtain our straight line. Then when we draw these 2 lines, we remark clearly that we have a point of intersection. This point of intersection, if we want to read its x, so we for example, we do we go down perpendicular to the x-axis to find that we are on the x equal to 1, and horizontally to the y-axis, perpendicularly to the y-axis to read a y equal to 3. So normally the simultaneous equation is our the coordinate of our point of intersection with x equal to 1 and y equal to 3. And we can also check that if the solution that we obtained in our graph is correct or not by substituting the obtained value x equal to 1, y equal to 3 in both equations. If these values verify both each equation of the given equations on both equations, so normally it is yes, our simultaneous solution. So it is easy that after drawing the 2 lines in each case, if the 2 lines are congruent, so identical, so we can see only one from by drawing these 2 lines. After drawing these 2 lines, we can see one and only one line, straight line on our paper. So normally these 2 lines are congruent. Like here, for example, are congruent. So they have infinite numbers of simultaneous solutions. Okay. And if the 2 lines are parallel, so normally they haven't any solution because they haven't any point of intersection, and only in the case when the 2 lines intersect each other, so we have 1 point of intersection, so of course 1 simultaneous solution. Okay, so for example, in the part I, if we can clearly, first of all, analyze these 2 equations, we can remark clearly that if we multiply the first equation by 2, all the terms of the first equation by 2, 2 by 1, 2x, 2 by minus 2 minus 4y, and 2 by 4 is equal to 8. So normally these two equations are equivalent and have the same, are the same. Okay, so normally to have the same equation, we can multiply it or divide it by the same value. So normally, after drawing the table of values, and using 3 particular points for each, we draw our line. And when drawing our line, we remark clearly that when we are going to draw the second one, we will obtain the same line. So we are in the case when the two lines are identical. So actually, we can say that we have infinite numbers of solution. Okay, these are the main ideas of our section. Thank you for listening. Have a nice day.